before the student
Okay.
before the student jumps off the bridge, she has a store of girl. She has a store of kinetic energy.
Before he jumps, how can he have the kinetic energy? Please tell me. I have told you that what does the kinetic energy means. What, which body will have kinetic energy?
Oh, because she's still at the moment.
Yes. So she will not have kinetic energy because she is not moving.
So elastic she can't have.
Uh, yes.
Gravitational potential. Yeah, no, wait. She, yeah, she will have gravitational potential energy, I think,
Absolutely right. But why?
because when she's at the top of the bridge, gravity is pulling her down.
Yes. And the bridge is doing the work to lift her up against the gravity, and she had attained certain height. So it means that gravitational potential energy, the formula of gravitational potential energy is mgh. She is having certain height. There is a gravitational energy constant, and she is having some mass. So it means that she will have the gravitational potential energy, right?
Yeah.
Okay. So in the next step,
When she is falling, the student store of um kinetic energy.
of course, because when she falls, she is having some speed. She is moving. So it means if a body is moving, it means that it will have kinetic energy in it, right?
Yeah.
Okay. Then moving forward to the third step.
When the bungee cord is stretched, the cord stores energy as elastic potential energy because it is stretching.
Exactly. We have
And there's an
studied today that the energy in a body due to stretching or compression is called the elastic potential energy. So when the bungee cord is stretched, it means it will have certain amount of elastic potential energy.
yeah.
Okay, great.
Yeah, that's it. Yeah. Should I do the next one now?
Yes, sure, sure.
Um, at the lowest point of the jump, when the student is stationary, the extension of the bungee cord is 35 meters. The bungee cord behaves like a spring with a spring constant of 40 newtons meter. Calculate the energy stored and in the stretched bungee cord. Use the correct equation from the physics equation sheet.
Can you
So
solve this?
yeah,
Do you
so
remember the formula?
yeah, is it E equals half KE squared?
E is equal to half kx square or ke square, and
Yeah,
k is the spin constant, it is given over here, and e is the amount of extension which the body or the bungee will get stretched, the amount which the body will get stretched. So it is also given here that it is 35 meter. So we will just plug in the values and we will get the value of elastic potential energy. It's very
yeah.
simple, I guess.
So K is spring constant.
Yes,
So that would be 40.
yes, exactly. And
And then the extension is 35 meters
exactly,
squared. So we would do
we will take the square of it.
40 times 35 squared. That is 4,000. Oh, 49,000.
Yes. And
And
then we
then we
need to
need to
half it.
half. Yeah. and then we divide it by 2. That gives 24,500 joules.
Exactly. So this is how we will
Yeah,
solve
joules.
this simple example, right?
Yeah.
So
And it can't it be 2.45 kilojoules as well?
yes, we can write it in kilojoules as well. We can, because
Yeah.
kilo is just a prefix, we can just use that as well.
Okay.
Okay, so moving forward to the third question,
The
we have.
diagram shows the 10.
Uh,
Yeah.
do you want to ask something? Please carry on.
Oh, no, it's fine. No,
Uh,
it's fine. I was gonna read it out.
okay.
So,
Your voice is a bit shaky. I couldn't understand it properly.
oh, sorry. No, one second. Is it better now?
Yes, I can hear you now.
Okay. The diagram shows a tennis ball thrown vertically into the air. Go down. Yeah. In position A, the ball has left the tennis player's hand at a speed of 5 meters per second. A tennis ball has a mass of 0.058 kg. Write down the equation that links kinetic energy, mass, and speed.
Okay. Do you watch tennis? Have you seen any tennis match on television?
I've seen it before. Yeah.
Okay. So you see how they serve. They just take the ball in hand and then they just throw it in the air, and then they just you can say push it with the tennis racket, right?
Yeah.
So it is showing that first phase when the server just pushed the ball in the air. He just threw it in the air. The ball lifts from his hand to the point A at in the air, right?
Yeah.
So you can imagine that, right? If you imagine those things physically in the real life, so you can easily solve these things. That's why I just gave you a lot of practical examples, so that I think that we can understand in a better way by thinking of the practical examples. So if you can imagine that, so it will be a lot more better. So in the first question, what it is asking, it is asked that you need to find an equation, you need to write an equation which connects kinetic energy, mass, and speed. I hope you remember that equation.
So kinetic energy
Yes.
is energy equals half mass times, I think it's speed.
Speed and velocity are
Speed.
same thing, right?
Yeah.
So speed square. So that is the equation we need to write over here. You are absolutely right. Absolutely right. Kinetic energy is equal to half mv square. So this is the equation which is asked in this particular question. So moving forward, what what it is asking here?
Calculate the kinetic energy of the tennis ball at position C.
Okay, so you can again read the data from here in order to find out the kinetic energy at point C.
So at the moment the ball is stationary in the person's hand. Therefore, there isn't any kinetic energy at the moment.
I want you to read it once again. You are just missing something in the data. You can read it from the top, the data given at the top of this question. Can you read it again?
So at the moment, there isn't any velocity in the ball as it is kept stationary. Therefore, there isn't any kinetic energy in the ball.
Tala, read the question again. You can see over here, it is written that at
Oh,
position C, the ball has just left the player's hand. at a speed of 5
Oh,
meters per
okay.
second. So it is not stationary, right?
Yeah.
So you can now better understand this. You will just put the values of this velocity, the velocity times square. It will be 25, and you will multiply it with 0.058, and then you will half the value in order to find the kinetic energy. Simple is that, right?
Okay. Yeah.
So it was not stationary. This was the simple, a little mistake you were doing. Otherwise, you were using the right concept if it would be stationary. So moving forward to part C.
Position A, the tennis ball is at its maximum height. What is the gravitational potential energy of the tennis ball at position A? Ignore the effect of the air resistance.
So can you? This is a bit tricky question. This will just give me a guess of your level of understanding that what you have understood. Now answer this carefully. Answer this question carefully.
So,
Should I tell you?
1 second now.
Okay, take your time. Take
But
it easy.
because when the ball is at the maximum height, it's
Mhm,
about to go down
mhm,
because of the gravitational potential energy.
mhm.
Um, wouldn't I'm not sure. What can you please
Okay,
tell me?
okay, Tala. Just have a focus on one thing. Right. This is position A. This was position C when the ball was leaving. At position C, the body had the maximum velocity and it had some kinetic energy, right? We had
Yeah,
calculated it in the first part. Now you left that body, left that ball. It went to position A, and then at the position A, for a little moment, for a nanosecond, it just stopped over there, and then it moved back, right?
yeah,
Now, when it stopped there, it means at that particular point, it will have no kinetic energy, right? Because it had no
yeah,
velocity at that particular time, right?
yeah,
So, from the law of conservation of energy, we have studied that we cannot lose the kinetic energy. Sorry, we cannot lose any type of energy. We cannot destroy any type of energy. So at that point, if the kinetic energy is zero, it means it is converted to some other type of energy, right? So at that point, it had some height, and at that height, it is having some height. So it means that the kinetic energy which is decreased with the height will be converted or will be transferred to another store of energy, which will be great gravitational potential energy. I have told you earlier as well that when we lift something, it means that its kinetic energy is being converted to the gravitational potential energy. So at the lowest point, the body will have the maximum kinetic energy and zero potential energy, because at this point it will have no height, and at the maximum point it will have zero kinetic energy because there the mass is sorry, the velocity is zero. So at that point is the kinetic energy is zero. It means that all the kinetic energy is converted to the potential energy. So and in the part B, we have calculated the kinetic energy. So in part C, we can just write the value of that kinetic energy, that this will be the potential energy the body will having at point C, right? Oh, sorry, at point A. I hope you understood that.
yeah.
If you have any doubt,
So,
I can explain it again.
right. So what you're saying is because there isn't any kinetic energy, it has to be transferred to gravitational energy,
Gravitational potential energy,
potential
exactly,
energy.
because it is written that you need to ignore the effect of air resistance, because if there is an air resistance, it means that we are, when the ball is moving upward, it means that some of its kinetic energy is being used for doing work against the air resistance as well. Against some of the work will be done against the gravitational energy, and some of the work will be done against the air resistance as well. But in this case, here we have no air resistance, so it means all the kinetic energy is used for doing work against the gravitational energy. So all of the kinetic energy is converted to gravitational potential energy, right?
Okay, yeah.
I hope it is clear. If you have any doubt, you can ask.
No, it's all right now. I get it now. Makes more sense.
That's great. Okay, moving to part D. Talha, can you hear me? Hello.
Yes. I know I couldn't hear you for a second. Yeah.
Talha,
Can you
please
hear me?
read the part D.
Okay. At position B, the tennis ball has 0.38 joules of gravitational potential energy.
Right.
Write down the equation that links gravitational field strength, gravitational potential energy, height, and mass.
So you can write.
So the the equation for
Hello. Hello. Hello, Talha. Can
hello.
sorry, my connection was a bit unstable. Can you hear me now?
Yeah, no, it's better now.
So,
Yeah.
let us continue that question.
Question D, right?
Right, right,
Yeah.
exactly.
Write down the equation for the network too. So the equation for gravitational potential energy was it mgh?
Yes, exactly. That was the equation. And what was G in that?
The gravitational field strength.
Gravitational field strength or gravitational acceleration, right? The gravitational
Yeah.
constant is represented by capital G. It's some different, it is something different, right? So it is not gravitational constant. Instead, it is gravitational field strength or gravitational acceleration.
Okay.
So E is equal to mgh. Exactly. That was the right answer. So now moving towards the party.
Oh, party. Calculate the height of the tennis ball above a table in position B.
So can you find that?
Okay, the height. Probably so. Um. Okay. So we know that the joules is 0.38.
Okay. It is the gravitational potential energy. So E is
Oh,
given.
so yeah, we're trying to work out the height.
Yes.
So
We know the value of G. G is constant, which is 9.8 meter per second square. It never changes. So
yeah,
we are only left with the mass, and mass of the ball is given at the start of this question. So we just rearrange this formula as H is equal to E divided by mg, and we just put the values. E is equal to 0.38 and the mass 0.058 kg, and the value of G, which is 9.8 Newton per kg or meter per second square. So when we put all these values, then we will get the value of the height the ball will attain at point B. So is it
okay,
clear to you?
yeah.
I guess it's enough till here.
Um,
Or
yeah.
should we do a few more questions?
How many more? What's the next question?
Let us see. There is question about uh, motor and pulley and load of the string. It's easy,
Oh,
but I guess it's a bit lengthy. So we can
yeah,
do it in the next class.
yeah, let's do it in the next lesson then.
Okay. So I will forward this worksheet to you for your practice, and you can practice these questions as well by yourself, and we can discuss it tomorrow because all these questions are related to the topic we have already studied. So we will discuss it tomorrow in the second half of the class as we did it today. And for
Oh,
now,
okay.
I guess it's enough.
Yeah, okay, yeah.
Okay, Tala, that's great.